Know Your IS Code Provisions short lecture series. I am going to explain today two plan irregularities from IS 1893. So these plan irregularities are, one is offset, vertical offset, and the second one is non-orthogonal frames. So let's go into the details. Yeah, know your IS code provisions. Now, clause number 7.1, that is regular and irregular configurations. In that, so table number 5, planned irregularities. So first one is point number 4, out of plane offset, and point number 5, that is non-orthogonal frames. So let's go to the first one, that is out of plane offset. Now, out of plane offsets in vertical elements resisting lateral loads cause discontinuities and detours in the load path, which is known to be detrimental to the earthquake safety of the building. Then, now a building is said to have out of plane offset in vertical elements when structural walls or frames are moved out of plane in any story along the height of the building. So let's look at that in detail. Say like one lateral vertical element, this is second vertical element, third vertical element, and you can see here this fourth vertical element is not directly coming down. So there is some offset here. So what will happen is this will cause a detour of the load path. So proper load path is not there. So that the earthquake, the force induced due to earthquake, that is at the diaphragm level, has to be transferred to vertical resisting element and from there to the base. So in that there is a discontinuity in this path. So what will happen? This discontinuity is there. So indirect load path is there, leading to stability issues. Now let's look at with some more clarity. So in this building, there are like frames and shear walls. So these two shear walls are there at the edges. This is in the ground floor. And when it comes to upper stories, shear wall in upper stories, you can see there is a offset here. So this is in plane discontinuity. The shear wall is there in the same plane, but it is discontinuous. And this is shear wall in the upper floor. This is out of plane discontinuity. So here, which is on the right side extreme right side frame, it is shifted one panel inside. So here out of plane discontinuity is there. So in such cases, what will happen is huge demand on columns in lower story will take place. So if at all any building is in that situation, what code specifies? What are the code clauses in that? Let's look into that. So in a building with out of plane offsets in vertical elements, so what code suggests is first, specialist literature shall be referred for design of such building if the building is located in zone seismic zone 2 and in other 3 zones, that is zone 3, zone 4 and zone 5. What code specifies is lateral drift shall be less than 0.2% in the story having offset and in stories below. So usually this lateral drift is 0.4%, but in this like floor and below floors where this out of plane offset is there, code is restricting the lateral drift to be 0.2%, up to 0.2%. And also what it says is specialist literature shall be referred for removing this irregularity arising due to out of plane offsets in vertical elements. So code is encouraging to go for look at literature in other codes, say for example American codes or Euro codes or New Zealand codes or any other code which where this clause is mentioned. Okay, this is for removing the irregularity. Now let's look into another clause which is non-parallel frames. So buildings undergo complex earthquake behavior and hence damage when they do not have lateral force resisting systems oriented along two planned directions that are orthogonal to each other. So let's look at the figure. So you can see this frame and this frame both are orthogonal to each other, but this frame and this frame are non-orthogonal. They are not orthogonal. It means the angle between them is more than 90 degrees. or you can see the moment frame along with the shear walls. Okay, the shear walls are not oriented along orthogonal directions. So in such case, what is going to happen? So a building is said to have non-parallel system when vertically oriented structural systems resisting lateral forces are not oriented along two like principal orthogonal axis of axis in plan. So buildings with non-parallel lateral force resisting system shall be analyzed for load combinations mentioned in clause number 6.3.2.2 or 6.3.4.1. Now, what actually the gist of the clause is, in any direction, so when orthogonal directions, frames are aligned along orthogonal directions, then earthquake load in X direction, earthquake load in Y direction, building can be analyzed for earthquake load in X direction and earthquake load in Y direction independently. But when such kind of non-orthogonal frames are there, then in X direction, 30% of load from Y direction has to be taken, and in Y direction 30% of X load has to be added to Y direction, and then building has to be analyzed using three-dimensional building analysis. So here in one direction, full earthquake load of one direction plus 30% of earthquake load of the other direction will have to be taken as a corrective measure for this non-parallel frames, non-orthogonal frames. So this short lecture is intended for students and practicing engineers understand IS code provisions in a better manner, and following references are used in the preparation of these slides. And I sincerely acknowledge my PhD students and master students for their help in preparation of this material. So thank you and have a nice day.